culture and globalization. I'm not sure exactly what that means, but we're all health and medical texts. But anyway, we've done a lot of QCA work with health and medical related data. So welcome, and take it away.
All right.
Wait.
Okay, good. All right, well, thank you for having me here. As I said, my name is Claude Rubinson. I've been working in QCA for, well, since my PhD program, so 10, 12 years at this point, for quite some time. We have an hour today, so what I want to do is provide a basic introduction to the technique. I'm assuming most people here have not used it. Anyone here who has or is familiar with it at all? Okay. And so I want to sort of provide a basic introduction to the technique, what it can be used for. I'm not planning on getting into the math too much, but if you have questions about it, I'm happy to answer those questions. Here's the overview. In particular, I want to begin with resources and publications and stuff for further study if you're interested. And I'm pretty informal, so if you've got questions, just go ahead and raise your hand and ask questions. It was originally developed in the mid-late 80s by Charles Reagan. He was my PhD advisor. And the primary text that he has on them, Redesigning Social Inquiry, this is the one, if you want to learn QCA, that's the one you have to purchase. And it's excellent, it's short, and it's relatively inexpensive, which is nice, like it's less than $20. The classic text is the comparative method from 1987. It is a phenomenal text. It's one that people do not read nearly enough. We just had the 30th anniversary of it, and I was asked to sort of, say something about the text, and I said, well, it's a text that I really love and really hate because it's a brilliant, brilliant text. The thing is, I'll be working on some project, some issue with QCA, and I'll be working on it, and I'll find that Reagan talked about it back in 1987. It really is well worth going. And then he and I have a couple of papers together that provide a short introduction to the technique. This distinctiveness of comparative research sort of addresses comparative research overall. And then this comparative methods text as article as well. These are all available on my website, so you can Google my name, and I will put these slides up on my website. So my professional website is here, and then personal. Okay. Other sources to look at. So the COMPAS website. So COMPAS is the International Inter-University Consortium for QCA. It is run by myself and one other person who founded it. It has sort of announcements about training seminars, conferences that are QCA related, and then it has a couple of resources. We have a bibliography of basically all books. It's as a WCAT list that are QCA related, and we have a bibliography that we try to maintain of all QCA related publications. It's perpetually out of date, but it has currently over 700 articles in it. And then there is a working paper series. And I am the editor of the working paper series, and that's a nice place if you're doing QCA to submit, and then you get reviewed by myself and at least 2 other people that get feedback and that. Other texts, this rating of this textbook, Intersectional Inequality, this is Reagan's latest textbook. It's a very nice reanalysis of the bell curve data, if you remember the bell curve from the mid-90s, but done using QCA. Charles has this other 2000 textbook, Fuzzy Set Social Science. It is largely obsolete. So people sometimes go to read that. It's there's some good stuff, but it's largely been surpassed by redesigning inquiry. And then there are 2 sort of textbooks on QCA, the Schneider and Bottom Set Theoretic Methods for Social Sciences, and then Ryu and Reagan Configurational Comparative Methods. And those try to sort of step you through how to do analysis. There are a lot of software packages for conducting QCA. And this provides sort of a lineage of them. The original one, QCA, came out in 1992. And the ones that are in bold are the ones that are currently maintained and actively developed. The ones that I recommend, so there is an R package if you use R, but the ones that I recommend are FSQCA, written by Charles Reagan and collaborators, and then my own software, Kirk. Kirk is a graphical program, ACQ is a command line Unix program. These tend to be certainly the most user-friendly of software packages. So those are the ones that I recommend. The dotted line here is to note that QCA Pro is a fork. It's also an R package. It's a fork of the QCA one. It's changed a bunch of the default settings. So you will get different results using QCA Pro than QCA. All of these packages will give you the same results. They all use the same algorithms. Okay. Varieties of QCA. So when you get into the literature, you'll find that there are sort of 3 main types of QCA that people talk about. People distinguish between crisp set QCA, fuzzy set QCA, and multi-valued QCA. The difference is with crisp set, all of your conditions are dichotomous. So all of your data is 0 or 1. With fuzzy set, you can have within the 0 to 1 interval. Okay, so 0.9, 0.8, 0.1, and so forth. The comparative methods textbook describes crisp set. That's what was sort of the original version of QCA. That's all we had for a long time. The fuzzy set social science book, it actually describes something that is not actually QCA. It describes fuzzy set analysis. And this is one of the reasons why I say it's sort of obsolete at this point. We realized, so as shortly after QCA was developed, one of the first critiques was that, the data had to be dichotomous. And so it took some time to sort of figure out, okay, how can we have within that range, and to figure out how to do fuzzy set analysis with QCA. What we eventually realized was that crisp set QCA was simply a special form of fuzzy set QCA. And so now I generally just refer to QCA. You will still in the literature see a lot, we're doing CSQCA or FSQCA. But the redesigning social inquiry text unifies these. That's just stating again that all the major packages are all based on the algorithms that are described in redesigning social inquiry, which simply build off of the original comparative method tests. You will also hear about multi-valued QCA. Is something that is not supported by most of the software. Just Smana supports it, and the QCAR package does as well, but neither FSQCA or my own software supports multi-valued. Basically, with multi-valued, it allows you to have values like 0, 1, or 2. And it's used when you have nominal level variables. So if you had race, right? White, black, Asian, Latino, you could put that all as one measurement. You can do that with CryptSet. It's straightforward to your white, non-white, black, not black, Latino, not Latino, just the same way as doing dummy variables. So you don't really need multi-valued QCA, and very few applications of QCA actually use it. All right. So I've used this term QCA over and over again, but I haven't actually explained what the heck it is. So QCA stands for Qualitative Comparative Analysis. That is because it is a formalization of comparative analysis using Boolean algebra. Okay? So this use of Boolean algebra is what really makes it distinct from conventional statistical analysis, which is based on linear vector algebra. Comparative research goes by lots of different names. Comparative research, comparative analysis, small n comparison, small n analysis, and so forth. What comparative analysis is always seeking to do is to identify invariant relationships. That is, looking for characteristics of your cases. That could be practices, patients, hospitals, whatever it is, characteristics of your cases that co-occur across different sets of conditions. In particular, what this leads to, and I'll explain more what I mean by invariance in a minute, but in particular, what this leads to is analyzing necessary and sufficient conditions. Okay? And this is a different thing than in conventional statistical analysis. In conventional statistical analysis, you're interested in analyzing covariation, right? As the value of one variable increases, the value of another variable increases. Here, we're interested in what are conditions, situations, characteristics that are necessary for an outcome to occur. What are conditions, characteristics of cases that, if they are present, they are sufficient for the outcome to occur? It's a different way of approaching conducting empirical research. In the past, QCA and comparative research have been restricted to small and moderate sample sizes. Comparative historical research in particular, you rarely would see an analysis of more than 10 cases. They would be sort of in-depth case studies, and then people would compare them together. And if you're doing this really rich sort of historical in-depth case analysis, you can't do much more than about 10 at the maximum. QCA, by formalizing this technique and being able to implement it in computer algorithms, let you sort of bump that up to about 50. And so when QCA came out, most of the applications were between 15 and 50 cases. Since then, and with some developments of the technique, now it's really sample size independent. And probably the most rapidly rising area in QCA is large N analysis. So now it's not unusual to see hundreds of cases or even thousands of cases. So comparative research is not necessarily small n. There is discussion about whether comparative research is necessarily case-oriented. There are people who use QCA and really focus on the variables, or the condition is the terminology that we tend to use. But most people who do QCA see it as a case-oriented perspective, one in which we really sort of pay a lot of attention to the individual cases. And what we do is we're comparing these cases and the types of cases to one another. So sort of the underlying question in QCA is always, how do these cases group together? What do they have in common? What don't they have in common? And how are those similarities and differences related to the outcome that I'm studying, whatever that might be. Right, let's stop there and see if there are any questions right now. Okay. So, what do I mean by invariant relationships? It's simply the idea that certain aspects of cases tend to co-occur, that they hang together in practice. So, a couple of examples. Tenured faculty tend to have many publications. Religious fundamentalists tend to be politically conservative. The influenza virus causes the flu. HIV causes AIDS. And we go through these in a little bit more depth. What we're talking about here are set theoretic relationships. This is what QCA fundamentally does, is it identifies sets and how sets intersect with each other. When we say tenured faculty tend to have many publications, what we're saying is there are a bunch of people out there who have lots of publications, and a subset of them are tenured faculty. Just because you have a lot of publications doesn't mean you're a tenured faculty member, and just because you're a tenured faculty member doesn't mean that you have lots of publications. There are some tenured faculty members who don't have any publications. You tend to hate them. But there is an overlap. There is a significant, or I shouldn't say significant because that's more conventional statistics. There's a substantial overlap that when you have tenured faculty, they often have many publications. Religious fundamentalists tend to be politically conservative. That is, if you're a religious fundamentalist, you're probably also a political conservative. Not always, but probably. But just because you're a political conservative does not mean you're a religious fundamentalist. This asymmetry is a key characteristic of QCA. This is very different than conventional correlations, right? Where the correlation between X and Y is the same as the correlation between Y and X. Okay? QCA does map and analyze this asymmetry. All right, losing my.
The update keeps getting in our way.
Oh, is that what's going on? Thank you. All right, so when we say influenza causes the flu, we are invoking a set theoretic statement. Underline that. That is, there is an overlap between the set of people who are exposed to influenza and that set of people who have flu-like symptoms. Those people who have the flu are a subset of the people who are exposed to the virus. There are people with flu-like symptoms who have not been exposed and do not have the flu. But again, this is a subset relationship. And this is one thing that QCA does, is it makes these set overlaps explicit. And that can often help you to sort of think through causation and causality. QCA is a descriptive technique. It's not a technique of causal inference. It's a descriptive technique. But by understanding these subset relationships, you can then say, okay, is there a relationship between being in this one set and being in this other set? And indeed, there is. HIV causes AIDS. This is a set theoretic statement as well. What we're saying is there is a disjuncture between the set of people who are HIV negative and the set of people with AIDS, right? If you are in the set of people who are HIV negative, you are out of the set of people with AIDS. You can invert that, of course. The set of people who are HIV positive is a superset of the set of people with AIDS. Right? Just because you're HIV positive does not mean that you have AIDS, but if you have AIDS, you are HIV positive. Questions? All right. So how do we map these invariant relationships? As I mentioned, we can do it in crisp, where things you're in the set or you're out of the set. We can also do it fuzzy, which is you are fully in the set, you have a score of 1.0. If you are mostly in the set, we give you a score of 0.9. And then if you're mostly out of it, you will get a score of 0.1 or something. So, and that's the idea of like, is someone rich? We would have to define what we mean by rich. But if someone was definitely rich, we'd say they're 1.0, but they're mostly rich. We'll say 0.9. What we're looking for here, and I'll give you some more examples of this as we go through, in a necessity relationship where you have a necessary condition, the outcome is going to be a subset of the cause. Right? And you can go back to, you need to have HIV in order to have AIDS. With fuzzy sets, what you're looking for is a lower triangular plot. Your data is always going to be on the 0 to 1 scale. So 0 to 1, 0 to 1. In a analysis of necessity, what you're looking for, and we can talk about exactly why this is, but for now, just trust me on it. This is the fuzzy set math. Is you're looking for your scores on X to be greater than or equal to your scores on Y. You can have, so you're looking for stuff to be sort of under the diagonal. If you have a few over the diagonal, what you might say is this condition, X, whatever it is almost always necessary. Right? Similarly here, it's almost always necessary. Because sometimes you can have the outcome without having the cause. For sufficiency, it's just the reverse, right? The inverse, I should say. Here, what you're looking for is that the cause is a subset of the outcome. Okay? That you have an upper triangular plot in which your Y values are greater than or equal to your X values. We'll give more examples of this. All right. Some issues about studying invariant relationships. It's simply the idea that these aspects of your cases tend to co-occur, that belonging to one set is associated with belonging to another set. Sometimes people interpret this as implying determinism, that things can only be one way. There's been some debate about this in the literature. That is not the case. It also doesn't necessarily say anything about probabilities either. It's simply a descriptive technique that things tend to overlap. One critique that comes out is that if you have one case that doesn't fit, then that means that you don't have any results. And that is not the case, because something can be almost always necessary, right? It's almost always necessary to have lots of publications in order to get tenure. But it is fundamentally set theoretic. And this is probably the biggest hurdle in learning QCA, is moving out of the conventional statistical net effects model and starting to think in terms of sets and set relationships. Really, part of the hardest part is simply using set theoretic terminology. It's very easy to slip back into talking about variables, but when we're trying to write up QCA results, we're not talking about variables anymore. We're talking about sets and set membership, and that can be challenging. What is very nice about it, though, is it really does parallel how we think about causation. Most of our theories really are about, if you're a member of this set, then you're also a member of this other set. You also have this outcome. Very few of our theories are in the sort of conventional statistical model, like, well, as your score on this variable increases, we also predict your score on this other variable to increase. we're often really interested in qualitative changes that cross a threshold from being not sick to being sick, right? Rather than looking at these relative effects. And so the way that we think about causation, right? A subset of people exposed to influenza will contract the flu. Therefore, to avoid getting sick, wash your hands. What we're saying when we say to avoid getting sick, wash your hands is you want to change your set memberships, right? So washing your hands hopefully reduces your exposure to influenza, and therefore you will be prevented by joining the set of sick people. We also know that our interventions often only work under particular conditions, that is, within particular sets. So a lot of health services interventions, they'll work at one type of hospital, but they won't work at another type, right? And that can be because of size, or it can be because of funding, or whatever it is. But we're often trying to distinguish these different types of hospitals or practices or patients or whatever it is, and trying to understand that context. Questions? Yeah.
Sorry, this is back a few slides. I was curious to understand better where you said the team would have to decide, for instance, 0.9 is highly example. But I'm thinking more about the process or how that 0.9 and the meaning between maybe the team deciding 0.7 versus 0.9.
Yeah, so I'm talking about this a little bit more, but the simple answer, you have to have expertise and you have to have domain knowledge. You have to know your cases. You have to know your theoretical background. You have to know your data. You have to know this area to be able to say, yeah, this is what it means, to be a 0.9. One of the things that in sociology and political science, often to analyze countries, we use GDP per capita, right? And it's a great variable, right? And we know it basically parallels average income and this kind of thing. With a conventional statistical analysis, you just take that variable and you throw it in and see if it correlates with other variables. But with QCA, you have to transform that variable, what we call calibrate that variable, such that it is measuring a developed country. And so what does it mean for a country to be developed? What level of GDP per capita counts as developed? Or a rich country, which is a slightly different idea than a developed country. And you have to have domain knowledge to be able to do that. And that is another thing that is challenging with QCA, is you can't just sort of take a variable and just throw it to your analysis, because exactly as you asked, you have to, what does it mean for it to be a 1.0? What does it mean for it to be a 0.7? There are some techniques to help facilitate that, but ultimately it comes down to your understanding of the project that you're engaged in. Other questions? Yeah.
So what would be the difference then versus like taking your previous variable and just making it a categorical variable? So defining it with using your GDP example, just defining cutoffs for it.
That is the process. The issue is, where are you going to select your breakpoints? So what is that 1.0 when you take GDP per capita? What level at which are you going to define? You're fully in the set of rich countries. You're partially in the set. You're not in the set at all. It's bringing that knowledge to say, this is what it means for a country to be rich, right? Or this is what it means for a person to, I don't know, be smart, or for a doctor to be poor, or whatever it is, right? You have to have that expertise to be able to define that. Other questions? So, what distinguishes QCA? This list seems to be getting longer over time. So, there is this assumption of invariance. There is an assumption of causal complexity. with conventional statistics, you are looking for a parsimonious solution, right? You're looking for sort of the best fitting line. You're looking to simplify your analysis or simplify your model so that you have sort of one clear model that you can present. And things like outliers, extreme cases, they disturb that model, and so we often just chuck on it, right? We say, oh, we got an outlier, we're just going to throw it out because it screws up the model, right? That's totally legitimate. QCA doesn't do this. It actually retains all complexity, and it is on the researcher to simplify. So we don't even talk about outliers or extreme cases in QCA, partly because everything's on a 0 to 1 scale, so you can't really be extreme. But what we talk about are anomalies. So maybe you have a large N study with a few thousand patients, and most of them fall into 3 or 4 groups, but then you have a very small number that fall into another group. You wouldn't necessarily just chuck those people out. Instead, they could be retained through the analysis and show up throughout the analysis, and you could decide whether you wanted to retain them or not. This is very qualitative. So qualitative researchers, when they go into the field, they observe everything, they talk to a bunch of people, and they tend to keep the complexity because they feel that that complexity adds depth to the analysis. If they want to drop these anomalies, they can. And you can in QCA as well, but the default is to retain all the complexity. Similarly, we retain all the complexity of all of the intersections between the conditions. So in a sense, and don't go too far with this, but it's somewhat similar to running a fully saturated model with all interactions. That's where we start. In conventional statistics, we tend to start with a simpler model and then make it more complex as needed. With QCA, we start with all the complexity and then simplify if it makes sense. This assumption of causal complexity, this then does lead to looking for necessary and sufficient conditions. I'll talk more about that. And it also leads to this issue of there can be multiple paths to the same outcome. Right? We sometimes talk about it as you have multiple recipes for baking the same cake. But again, this is an aspect of causal complexity, this idea that you can arrive in the same situation from a myriad of different starting points often. Okay, QCA maintains all of that. I mentioned this, we don't have degrees of freedom restrictions. Why? Because we're not using vector algebra, we're using set theory, we don't have degrees of freedom issues, and therefore you can use it with pretty much any sample size. Super small stuff can be difficult, but there's no problem with medium N and even large N. The other thing that really distinguishes the method, and for some people this is the distinguishing characteristic, is that QCA generally isn't purely deductive or inductive. It tends to be retroductive in that you're moving back and forth between your data and your analysis. And so you often come in, when you're doing a QCA analysis, you often come in with a number of ideas that you want to explore, not necessarily hypotheses to test. So I think this might be what's going on, let me see. And the nature of QCA really encourages you to sort of move back and forth between your theory and data using this sort of what I call malleable analytic frame that you can adjust over time. You do have to identify, measure, scale your causal conditions and your outcome, and that honestly is often the most difficult, most challenging aspect of QCA. Figuring out what is a 1.0 and what is a 0.9, that is often very challenging. Your data set, this is something people don't always realize. You have to have both positive and negative instances of your outcome. So you have to have instances where the outcome occurred, as well as instances where the outcome did not occur. The method, some people refer to QCA as a diversity-oriented method for that reason. And it frequently you will run separate analyses explaining the occurrence of the outcome and another analysis to explain the non-occurrence of the outcome, because you might be interested in both of those. And I'll talk a little bit more about contradictions. Essentially, contradictions occur, let's say that you have a set of cases, they have the same characteristics, but some of them have the outcome and others didn't. That's what we call a contradiction, because the assumption of invariance says similar cases should behave similar to one another. If you've got these same characteristics in common, you should act the same. And sometimes, often, you don't get that. You get the outcome occurred in this case, but not in this other case. Resolving those contradictions, figuring out what is it that distinguishes those cases that have the outcome versus those that did not, that can really be the key to coming up with a good QCA analysis. And that does often require going back to your cases, immersing yourself in your data, figuring out what's going on. And that is often a much more inductive type of process. Okay. I've got an example that I want to give. Let me just quickly say, so there's these three aspects of a QCA analysis. They all impinge on each other, and this is part of the retroductive nature. So calibrating your data, that's rescaling everything onto your 0 to 1 scale, your necessity testing, and your sufficiency testing. It is often the case that you calibrate your data and then you run a sufficiency analysis and your results don't make a lot of sense. And you say, you know what, I bet my calibrations are off. And so you have to go back and sort of think about, well, what did I get wrong? Or you run a necessity analysis and that gives you ideas about what might be sufficient. Or your sufficiency analysis, you see the same conditions show up in all of your recipes, all of your pathways to the outcome, and you say, well, that's a necessary condition. So there's this sort of back and forth that you're always engaged in. And we do that in conventional statistical analysis too. We just don't talk about it, right? You're supposed to sort of, here's my hypothesis, here's my data, and now you test my hypothesis. You do the retroductive thing in conventional statistical analysis as well, but in QCA we try to be explicit and we try to be explicit about it. Questions?
How do you, related to that, how do you ensure that you're not making your data fit your underlying, maybe not statistically? So you can go back and recalibrate this.
You gotta have integrity and you gotta be careful and yeah, and just try not to do that. Be explicit about it. Yeah, I mean, that's the best thing I can tell you. Try to be as transparent as you can about what you did. Right? I think it's very valuable to make your data sets available if you can, and just be as clear as you can in, what are the transformations that you created.
So related to that, is there sort of a requirement that two coders agree, or are you doing this with a group or with a person?
It depends on the project. I've been on a variety of them like that. So sometimes it is simply I'm calibrating the data myself, and I say, okay, I know these cases. I'm assigning a score of 0.9 to this one and a score of 0.8 to that one. But I've also been on projects where you do have groups working on it, and what will happen is they go up, they sort of code things themselves, and we come together and talk about it and try to make sense of it. And a lot of it really is coming back to that question, okay, what is the set that we're interested in? What does it need to be fully in that set? But yeah, there are a lot of ways to do it. And then there are some automated procedures. If you have an interval ratio variable, there are some automated procedures where essentially you set your upper threshold, your mid point, and your lower threshold. and then essentially use a logistic regression function to scale things for you. But yeah, it is on the researcher to defend their calibrations. And that is an important point. Some questions? Okay, so this is a non-medical example, but it does a good job of sort of explaining this retroduction process. So this was an analysis of the US 1919 steel strikes, and in particular looking at strike breaking, and in particular when the occurrence of black strike breaking. So when did African Americans cross the picket lines? And the researchers, Cliff Brown and Terry Boswell, they identify all these instances of strike breaking, of black strike breaking, or I should say strikes. And then they do case studies on all of them. They hypothesize that black strike breaking would be affected by, was there a recent influx of black migrants to the city and the strength of the union. So they code up all of the strikes, and then and this is crisp, so did they have recent black migrants? Did they have a weak union? Did they have black strike breaking? This is what we call a truth table. It's showing the different types, right? So this first row is these strikes had recent black migrants and a weak union. The second row, recent black migrants, but a strong union. And then they didn't have recent black migrants, but they did have a weak union, and here we have neither. By and large, their thinking held. When they had both of these, they had black strike breaking. When they were missing recent black migrants, they did not. But the second row ends up being a contradiction. Why? Because these first four cities had black strike breaking, but Cleveland did not. Cleveland, in its characteristics, looks like these other four, but something's different, right? And so they go back to their cases. They say, what distinguishes Cleveland from these other cases? And they actually investigate three things. But what they find, let's see this. No, this is the full thing. No. So it got screwed up and cut off a little bit here. But what they find is the presence of local government repression. Did the local government side with the industry or the union is what distinguishes Cleveland from these other four. This is something that they would not have been able to figure out without having that contradiction in there, going back to their cases and saying, oh, something else must be going on. The way QCA works, okay, so you add in this additional condition, and it's going to double your property space, because what it basically does is it splits each of the existing rows. So this was one row before, because this is the group that had recent black migration and a weak union. But then it splits on the presence or absence of local government repression, and it resolves that contradiction. That contradiction goes away. You can continue with the analysis. What do we do in QCA for this type of analysis? We highlight those instances where you have the outcome, and we can now use sort of Boolean notation. What this is saying is that we've got one set of cases that have recent black migration and a weak union and local government repression. And then we had another set that had recent black migration, did not have a weak union, but did have local government repression. Both of these led to black strike breaking. And that's just describing this in Boolean notation. What this means is that the presence or absence of a weak union must not matter. Because in one instance you had it, in another you didn't, but you still had lax strike breaking in each case, and therefore the actual solution is that the presence of recent black migration and local government repression, that is what led to lax strike. That's QCA in a nutshell. And that is sort of a description of this retroductive process of going back and forth between your theory, your case knowledge, trying to make sense of the patterns that empirically exist. Questions? When are we done with this?
1 o'clock.
I just
1
want to
o'clock.
make sure I'm grasping this. This is a really good example. So in like a clinical setting, we have, let's say, multiple characteristics that we think might contribute to an outcome, and we've done all the calibrating. This would sort of help you identify this method, this combination or this combination of something being present, this combination of something not being present could potentially lead to one outcome or the other.
Yeah.
Okay. Perfect. Thank you.
Okay. You do have to learn a little Boolean algebra. It's pretty simple. I'm just going to go through this really quickly because we've only got 10 minutes. So uppercase for the presence of a condition, lowercase, or sometimes we use a tilde for the absence of condition. And they're basically just 3 main functions that we use. We negate stuff. We do Boolean multiplication, which is anding things together. And we do Boolean addition, which is ORing things. Okay, I'm going to talk about calibration, necessity analysis, and sufficiency analysis quickly. We've already talked about dataset calibration a fair amount. So maybe Chris was fuzzy about defining these set memberships, which is different than defining variables. So you've got annual income, but you want to define a set of rich people. What does that mean? You want to pay attention to negation and asymmetry. There is a difference between not being in a set of rich people and being poor. If you're interested in what does it mean to be poor, you have to calibrate that set separately from calibrating rich. Same thing for what's the difference between not being developed and being less developed, underdeveloped, third world country, whatever your preferred nomenclature is. Okay. You have to define, you have to calibrate all of your sets separately. Oh, we lost this. It is easiest to start with crisp set. You're in the set or you're out. The fuzzy set stuff is more complicated. All right. Analysis of necessary and sufficient conditions. I think it's crucial to do both necessity testing and sufficiency testing, but necessity testing has been underdeveloped in the literature. There has not been as much methodological work on it, and most applications of QCA are just on the sufficiency analysis. I don't recommend doing it, but that's what you will see. My own software, Perk, and ACQ have more sophisticated necessity testing, and it really, I've tried to put both necessity testing and sufficiency testing on equal footing in that software. Sufficiency analysis, we've talked about this a little bit. It assumes causal complexity. It's going to retain all of your cases unless you decide to drop it. And it emphasizes what we call multiple conjunctural causation. That is both intersectionality, this idea that it's the combination of conditions that explain things. In QCA, generally, you're not supposed to end up saying, well, this condition is what's most important. You say, it's these conditions working together, how they intersect, how they interact, that explains the presence of an outcome. Equifinality, the idea that you can have different combinations of condition that lead to the same outcome. Right? So you can have different explanations for black stripe breaking. Different ways that that comes about. Okay. Necessary conditions. This is the result of an analysis that we've recently completed. It's an intervention to reduce acute kidney infection in pediatric patients. And for our necessity test, what we found, so it's an analysis of 9 hospitals total. 5 of them within the first 2 years ended up getting a significant decrease in the AKI rate. The necessity test revealed that what was necessary was essentially this scrapping report that was going to be produced daily. If you did not get that produced within the first 6 months of the program start, you never did. But just because you did have it produced doesn't mean that you had the outcome. So, but if that didn't happen, that's the point of a necessary condition. If it's absent, it's not going to, the outcome is not going to occur. And so that's what we found there. There are 2 measures of fit that you'll have to use, consistency and coverage. I'm not going to talk about them too much here. They both are on the 0 to 1 scale. Identifying necessary conditions, you really have to apply theory and substantive knowledge. You have to know your cases, you have to know your domain. Does this make sense as a necessary condition? In this instance, this does, through this analysis. Sufficient conditions, I'm looking at the time, but I'm almost done. The idea here is that the outcome almost always occurs when the causal condition or combination of causal conditions is present. Again, you're also looking at consistency and coverage. They're calculated slightly differently for sufficiency. You're focusing here on these combinations of conditions, and you have multiple solutions being possible. Again, our outcome here is this significant decrease in AKI rates. We had 5 of the 9 hospitals that did have this combination, or did have this outcome, or did not. 4 of these hospitals had these 3 conditions. One was that a pharmacist champion with assigned time was assigned to the project. You had at least 2 pharmacists assigned to the project. And you had at least a report, these cramming reports, you had that build in progress. 4 of the hospitals that achieved this AKI reduction had those conditions, that combination of conditions. There was 1 that achieved the outcome in a different way. And that had to do with that they didn't have other delays from the organization, and they had essentially another type of champion. So this is, we have 2 separate ways of achieving this AKI rate decrease. All right. There are 3 basic types of comparative research projects, QC projects. The most popular one is uncovering causal recipes, just like this, saying, oh, if you have these 3 conditions, and we had lots of other conditions that we looked at. So does having a data champion matter? Does having a QI champion matter? Does going to monthly webinars seem to matter? These are the ones that showed up as explaining what was going on. Gotta figure this one out. Okay, so uncovering causal recipes is the sort of most popular use of QCA. And you'll see that's how it's usually described. But the other thing is identifying taxonomies and types, right? What types of cases do you have? This is what that truth table gives you. It says, okay, what conditions, how do they combine? If you have let's say 3 conditions, that will give you a truth table of 8 rows. How many of those rows actually exist? How many cases fall into another of those rows? Just figuring out what is the diversity of your sample can be really useful. We do usually do it along the way, but I've got a handful of analyses that really it's just the truth table that we're looking at. What's out there? And then analyzing context. QC is really good for analyzing context because it's, okay, what are the conditions under which an outcome occurs or does not occur? What contextual conditions do you need to have present? Which ones don't actually matter? And so that's sort of the third type of QCA project that you'll see. And I think that is all of my slides.
So I know I'm thinking too standard one, but when the example you presented with hospitals, you know, good hospitals, for example, tend to have good things.
Mm-hmm.
How do you get around the fact that a lot of these sets go together so much of the time, you can't tell what it is?
That's the whole point.
Yeah.
Right, so yes, often these aspects, the aspects of cases will co-occur. What you're often looking for is that one or those observations, those cases that are a little bit different. And that's how we can say, oh, see, they still have the outcome without having this thing. Therefore, we think it's not actually necessary. Now, that does put a lot of emphasis on the validity of that case, right? And that's another reason why it's a case-oriented method. You have to establish and defend that your cases can sort of support that argument. But yeah, that's why you're often looking for this diversity to see what really does matter. If we go back to the outline, just escape out. Just
There you go.
So if you notice here, these daily reports, 8 of the 9 hospitals had it, right? So you might say, well, it's just one that didn't have it. Is that enough to say that it is necessary? Our case knowledge says yeah, right? We realize that like, without that, it wouldn't make sense, and knowing the hospital that didn't have it, we said, yeah, that's what explains them not being successful, that they couldn't get to this point, right? This was indicative of other things going on in the hospital as well. That's definitely the case, right? And so you do have to go back to your cases and say, this is what's going on. Let's talk about the cases, right? It's not just this condition in and of itself. It is the case that matters.
I was just going to say, since we're out of time, I want to say one thing about working with this. But before that, please make sure to sign in and complete your evaluation. So there's a sign-up sheet somewhere right over there. What I just want to say is, having worked with this before, if you come up with junk, like you do your calibrations all wrong, you don't come up with the right thing, you don't get very good outcomes. So it's kind of like you can't. I mean, your first thought is, oh, I can just cheat this and make it turn out the way I want, and that's not really true. Because my opinion is like you just don't get very good consistency and coverage. It really just doesn't add up. So anyway,
I think it's the same thing as like
we should probably
teaching undergrads. Like cheating is a lot harder than just doing it properly. and it is the case that because if you're going to try to fix your data, you have to do it for all of your conditions. The whole point is that these things hang together. And so it's actually a pretty involved process. So,
thank you very much. You can stick around for like a few minutes if you have specific questions.
yeah, I didn't give enough time for more questions. I'll put my website back up here, but if you look at my name, you'll find me, and I'll put these slides up.
Who's the director of the board and also a pediatrician, so thanks for the pediatric.
Yes,
Oh.
love that.
Are you tomorrow? Okay, because I'm hoping to talk more about this project.
I said, everything great.
It's really hard. It's hard to explain this without getting into the weeds, you know what I mean?
Yeah.
It's like,
No, you did a great job.
what we're doing big picture, but
An hour is quick to give the
yeah,
overview.
But this is a great,
So-
approach. A lot of people.
So, I think we have 16, but we've also were able to so it's
Expertise.
very
For you.
Well, thank you, and thanks for your questions, yeah.
Thank you.
Exactly.
Propose, deduce, all the big ones, and then some of the ones. And it'll be,
This is what I just did.
XML code.
Yeah. Let me spell it. I'm trying to remember.
Okay, so it'll be all XML, and it'll be
It's very small.
So what they just done, they had 3 meetings where they actually have come together to work on projects, and they just figured out.
Oh, here's,
That's it. So, I mean, that was like an early win, like, let's do it, we'll have one time.
Basically,
All of the mapping is huge. It's been like watching your back.
Trying to make it look
black and red here.
Right, because they all have different terms for
Incidents.
things that are similar to things, like journal, like exactly what all those mean. Those, that was the big ones, like there's annotated comments and notes.
Oh, really?
And so now they have to try to implement that model, so I'm